Hey everyone, and welcome to this explainer on behalf of Forge College. Today we are absolutely thrilled to be tackling the principles of smart wallet interfaces. Now this is a super crucial lesson in our Patterns for Enhanced Usability module, which sits right inside the Designing Smart Wallet Patterns section of our Applied Solidity development track. You might remember that in our previous lesson, we went through the network selection checklist and considerations, making some pretty big structural choices about where our decentralized apps are going to live. But now we have to take all of that complex on-chain logic and actually wire up an interface blueprint for, real human beings. So today we're mapping out exactly how to build a rock-solid bridge between your smart contracts and your users. Because let's be honest for a second here. Why does using a crypto wallet almost always feel like defusing a bomb? Seriously, you log in, you just want to do one simple thing, and suddenly you're staring down a generic OK button sitting right next to a massive, terrifying wall of raw, unreadable hex code. It's basically asking your users to read the code from the matrix and just pray they don't accidentally drain their entire life savings. It's incredibly stressful, and from a design perspective, it's a complete usability nightmare. We're going to fix that today.
So here is our architectural blueprint for today's explainer. We're going to cover architecture basics, progressive disclosure, contract collaboration, signing flows, feedback and recovery, and finally wrap it all up with a blueprint conclusion.
All right, let's dive right in with sections 1 and 2, architecture basics and progressive disclosure. Okay, so if you want users to feel safe, and we definitely do, you have to control how much information you throw at them at any given moment. And that brings us to this beautiful concept, progressive disclosure. Basically, it's a design pattern that reduces cognitive load by keeping advanced controls hidden until the user explicitly asks for them. Think of it like a throttle for complexity. You want to expose a little bit right now and reveal more later on, but only when it's requested. Look, if a user just wants to approve a standard token transfer, there is absolutely no reason they need to see advanced custom gas settings or delegate key configurations right up front, right? You got to keep that decision surface incredibly small.
And we can actually apply that exact throttle directly to a proper onboarding flow. Notice the steps here. First, you establish identity and safe defaults. We're talking just a display name and some basic security hints. Super easy. Second, you provide a brief, interactive walkthrough to teach the primary tools, like simply showing them where to find pending transactions. And third, you defer all those advanced, scary-looking options. If you do this right, your user builds a comfortable, solid mental model of the interface without getting completely overwhelmed on their very first run.
Moving right along, let's jump into section 3, contracts as UI collaborators. Because here's the secret. A great interface doesn't just rely on front-end tricks. The smart contract itself actually has to act as a crucial collaborator in our UI machine. Let's break down these 4 key Solidity events. This is basically how a contract talks to a front end so that your front end doesn't have to desperately decode messy transaction receipts. First up, ActionProposed. This carries an action ID, the proposer's address, and crucially, a short, human-readable description. Next, ActionApproved emits when someone signs off, which is literally the perfect machine-readable signal for your UI to instantly update a little approval count badge. Third, ActionExecuted is your terminal event. It gives an immediate yes or no success or fail status. And finally, ActionError signals recoverable domain errors. So instead of the whole transaction just mysteriously reverting and leaving the user in the dark, the contract explicitly tells the UI exactly what went wrong, allowing you to offer a simple one-click recovery option.
So, the absolutely crucial point here is this. You need to treat events as a contract for visible state. By keeping your event schema stable and packing it with all that UI-friendly data, your front-end code isn't going to break every single time you tweak the internal logic of your smart contract. You basically stop relying on clunky, implicit state polling, and you start listening for explicit semantic signals. It's a total game changer.
Okay, on to section 4, designing clear signing flows.
Now this is without a doubt the most treacherous part of the decentralized dungeon. This is where users make irreversible mistakes. Just contrast these 2 approaches. On the left side, we have that terrifying, poorly designed interface we were joking about earlier. A generic OK button just floating next to raw call data. I mean, it tells the user absolutely nothing. But on the right, we're applying our new principles. We use a confirm and sign button paired with a crystal clear semantic summary of the transaction. We hide those long, scary hex strings behind a simple view details toggle for the advanced users who actually want to dig into it. This is progressive disclosure in action, and it literally saves the user from sheer panic.
So before you ever ask a user for explicit consent,
Your confirmation modal must answer these 3 critical questions as plainly as possible. Number 1, what will happen? Give them just one primary sentence summarizing the action. Number 2, who will sign? Visually display exactly which account is authorizing this. And number 3, what are the immediate consequences? I promise you, if those 3 answers are unambiguous, most users are going to make the correct decision without ever needing to parse raw transaction data.
Let's pivot now to Section 5, Feedback Loops and Recovery.
You know that absolute silence right after you confirm a transaction? Yeah, it is deafening, and that ambiguity causes immense user anxiety. We absolutely have to map out a temporal feedback loop to soothe that panic. In the first few seconds, immediately present an ephemeral state. Say something like pending, awaiting network. Don't just leave them sitting there wondering if the click even registered. Then, over the next few minutes, as those smart contract events we designed earlier start to arrive, update the UI to either confirmed or failed. And finally, always provide a durable activity feed entry with compact details so they can inspect the history on their own time without drowning in massive receipt logs.
So, this simple workflow matrix helps summarize how these deterministic components actually close that feedback loop. You've got your onboarding tour for the very first run, the confirmation model to collect explicit consent right before a signature, the details toggle to expose that advanced metadata on demand, the activity feed to always track the lifecycle, and an error banner to clearly explain recoverable errors right when an execution fails. By using these small, testable UI components, you are drastically reducing the number of ambiguous, confusing states that a real user is ever going to encounter.
But, what happens when things actually do go wrong? Because they will. Well, you need a clear recovery path. Think view details, then retry, cancel, or contact support. The mental cost of figuring out what to do after an error should be far, far lower than whatever mental cost led to the error in the first place. Oh, and actually, scratch that. The absolute best way to handle an error is to just prevent it entirely. Disable impossible actions client-side. If an approval threshold is already maxed out, just gray out the approve button. Don't even let them submit a doomed transaction to begin with. All right, let's bring it all home with Section 6, Blueprint Conclusion and Next Steps.
If you take away just one single thing from this entire explainer, let it be this golden rule right here. Treat the user as an expert in intent, not in technical detail. The user knows exactly what they want to achieve. It is your job as the developer and designer to guide that correct behavior with clear summaries, semantic buttons, and safe defaults, all without patronizing them or forcing them to read raw call data.
And trust me, you are going to need this foundational mindset very soon. And our next lesson in this module will be diving deep into multi-sig and social recovery patterns. We're going to take these exact event-driven patterns and signing flow templates we just talked about, and we're going to use them to tackle complex, aggregated approvals and recovery mechanisms. It's going to be a lot of fun.
So, I'll leave you with this question to chew on. Are you ready to stop building puzzles and start building bridges for your users? Because it really is time to make Web3 truly accessible for everyone. Thank you so much for joining me today on behalf of Forge College. Make sure you head over to forge.college to continue your Web3 journey, dive deeper into these smart wallet patterns, and of course, keep building better, safer interfaces. I will see you in the next one.